Let's try to figure out the torques here. So let's start by figuring out the torque from force 1. We want to go through our systematic approach and figure out each of these. So let's start with the torque from force 1.
I can't draw R, so that one's 0.
Good. R is from the point of application to the pivot point, but I actually should have specified that this is the pivot point. I should have told you that, otherwise you can't do this. So we are rotating around the center. We're rotating around the center. Well, then the distance from the pivot point to the force is 0.
Right.
So when R is 0, we know that the torque is 0. So we plug in the 0 for R, so that torque will be 0. That doesn't mean the force doesn't exist. It means it's not exerting a torque. Again, you know that. You can't make the wheel rotate by pushing on its center.
Right.
All right, let's figure out the torque from force 2. The radius of this wheel is 4 meters.
Okay.
Good. So what's your answer? What's that torque?
32 Newton meters.
Actually, that wouldn't be full credit because you didn't figure out the sign. Remember, that's what we should do first.
Yes.
So what's the sign going to be?
The sign would be positive, though. Right?
This is going to tend to rotate the wheel counterclockwise.
Okay.
Yeah, what you do there is imagine this was the only force. If this was the only force, it would tend to make a counterclockwise rotation. And counterclockwise is our positive direction. So what was the torque?
32 Newton, positive 32 Newton.
Yeah. If something's positive, it's better to actually put in the positive sign. No. Good. Now, one thing that you did that was excellent there is that you drew a whole new picture just to show the R. And in this case, what is F perpendicular? Was just 8, because the whole force is perpendicular to R. If the whole force is perpendicular to R, it doesn't take any work to find F perpendicular. So F perpendicular here was 8. Of course, all the radii are the same, so that gave us our 32.
Okay.
Great. Now let's try this one. This one we'll do together. Now the key thing to notice here, remember that we have two different approaches, F perpendicular and R perpendicular. Now remember that when you use the F perpendicular formula, it's usually best when you're given an angle. For example, here we were given this angle of 90. But notice here, we're not given this angle. Therefore, probably the R perpendicular approach is better. So we're going to use R perpendicular times F. Well, now we have to go down the right-hand column. And I have to explain, what does R perpendicular mean? R perpendicular is from the axis of rotation perpendicular to the line of the force. So we'll draw a new picture. So what's the line of the force? Well, the line of the force is what you get if you just extend out the line that the vector is on. So this is what the handout means by the line of the force. Now we need to draw a vector from the point of rotation, from the pivot to the line of the force. So you draw that in? Yeah. From the pivot point to the line of the force, this would be R perpendicular. You can see why it's called R perpendicular, because it's perpendicular to the line of the force. And you can see why you have to use the whole line of the force, because the force isn't actually drawn out here, but the line of the force comes to out here. All right, and now we really can just plug in to our equation. How big is R perpendicular?
2 meters.
That was given to you in the original problem. And what should I plug in for F?
8 newtons.
Notice that in this case, we don't use F perpendicular. Because we're using R perpendicular. So you either use F perpendicular or you use R perpendicular, but you would never use both of them. That would be double counting in a sense. So we don't need to break this into components. We don't need to break F into components.
Okay.
And notice that we don't really need to break R into components either. It was easy to figure out R perpendicular by just drawing from the pivot to the line of the force. So what do we get as the torque?
16 Newton meters. Oh, yeah, positive 16.
Excellent. I didn't follow my own advice. I didn't do the sign first. If I had done the sign first, there would be no chance of forgetting. Let's see, how would you get that here? So thinking about it here, I would think about, suppose that this force was being exerted on a lever like this. Suppose this was the lever. Well, this force would tend to cause this lever to rotate like this, which is a counterclockwise direction. So that would come out positive.
Okay.
All right, this is why you need to know this formula, this R perpendicular formula. And when is it handy? When you're not given any angles.
Right.
When you use the F perpendicular or the R perpendicular approach here.
F perpendicular.
So here's F perpendicular. How would you calculate F perpendicular?
You would do 4 sine theta.
That would be 8
Yeah.
times the sine of 15 here. We're using this method because we were given the angle. Okay, so the torque would be 8 times the sine of 15, and what do we plug in for R? That would be our radius again, of 4 meters. All right, so let's crank that second. Making sure you're in degrees mode. I got 8.3.
Yeah, me too. But this one's negative, right?
Good. So I would focus on just F perpendicular. And think about this as the lever.
Okay.
F perpendicular here would cause this lever to move like this, which is clockwise. So that is negative. Good. This is the one that people would tend to forget.
Okay.
This is important when you're using the net torque equation. You got to put in the torques with the right signs.
Right.
All right, so now I think we had some good practice on how to figure out all the various torques. And again, you can see why you need a whole handout for that, because there's a lot of work. Remember to draw the R vector. That's a very important step. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. Thank you.